Hello, today's video lesson is a simple one. We're going to be just basically, in the future we're going to learn how to analyze quadratic functions when they look like this. In class we identified this as standard form, and in standard form we're going to have to learn how to do our work just like we did with vertex form. One of the first skills we want to possess is we want to be able to see where all the solutions to this equation will lie in general. We're going to analyze to find really specific things like the vertex and the x-intercepts and everything else, but for today's lesson we just want to know a general sloppy picture of where the solutions should lie. And what I'd like to do is connect what we see here with this quadratic equation with what we studied previously with linear functions. You see, if I remove the x squared, I have the line y equals 2x plus 4. So to graph the solutions to this equation, I'm going to start by trying to imagine what y equals 2x plus 4 would look like. So you can see here, I have a y-intercept of 4 and a slope of 2, so I go over 1 up 2, and I draw this really thin line, as thin as I can make it, just to create a little shadow, if you will. Then recognize that all of these are y values that result in putting in x here, but I'm going to take more numbers and add them, add or increase the value. So all of these y values that form this line are going to be increased by x squared. When x is 0, x squared will have no effect. But when x is large, squaring x will have a big effect. So basically what I want to show is all the solutions are going to start from this line, but because of the extra addition of x squareds, I'm going to add value. I'm going to add a parabola. So I'm going to basically take this line and peel it upwards. See, if that doesn't make sense, just try this out and think about it for a little while, but just look at the other examples. See, I start by looking at this linear function, y equals 4 minus 2x, and so I have y-intercept of 4 and a slope of negative 2 this time. But once again, I'm going to take all the values on this line and increase them by x squared. Near the y-axis, it's not effective, but farther away, it's more effective. So the amount of the effect is going to effectively turn this line into an upward shape that looks like that. The only way you can add an x squared to this line is if you have a parabola that goes right above that line. Just like here, the only way you can add a parabola to the line is to have the parabola go above the line, so that right here on the y-intercept, the line and the parabola look virtually the same. Everywhere else they're divergent, but right down here by the y-axis they're virtually the same. Once again, draw the line. Really light, thin sketch, negative slope, negative y-intercept, and then I'm going to have a parabola downward. So in order to be able to take this line and fold it into a parabola downward, I need to go in that direction. So this is the way my parabola is going to look. The vertex will be in the third quadrant. And last but not least, negative 4 y-intercept, but a positive 2 slope this time. I draw that little shadow line, and then imagine a parabola that will open down by taking all of these values and subtracting some squared values. I'm going to get a parabola that looks like that. For some people, they pick this up right away. Other people, this is really challenging. Either way, it's a fact. It's something that you've got to learn, and the only way you can learn it is by doing it. So take the opportunity to practice from the assignment I gave in class and check it up on Haiku. All right, thank you.